But why? Tell us which postulate or theorem from our postulates and theorems so far justifies each of these statements. If you flip your page back, you'll see the most recent one is all of our postulates and all of our theorems so far. Let's take a look and quickly review these. I have 2 sheets right now, so I don't have to flip back and forth a lot. But here's what we have. So just remember, postulates is a statement which we agree is true. And a theorem is a statement which can be proven by a deductive argument based on the postulates agreed upon. So far we've proven one theorem, the vertical angles theorem. Before we prove any theorems, let's clearly state our postulates, which we will be using. The postulates for Euclidean geometry, different branches of mathematics such as topology, probability, spherical geometry, or number theory start with a different set of postulates. Ideally, the list of postulates are simple and don't include any redundancies. For our study of Euclidean geometry, we'll start with these 14 postulates and 3 theorems. Wow, that's a lot. Okay, let's just look through them really quick. I'll point at them with my ruler. Identity postulate, P1. Focus. Any quantity equals itself. 3 is equal to 3. 2 quantities equal to a third quantity are equal to each other. 2 quantities equal to a third quantity are equal to each other. Oh, that's like a plus a equals 2a, so therefore a plus a must be equal. If equals are added to equals, the sums are equal. We looked at that one. If equals are subtracted from equals, the differences are equal. We've seen that one. The whole equals the sum of its parts. 2 points determine one and only one straight line. A line segment can be extended continuously in both directions. A line segment has one and only one midpoint. The midpoint divides the segment into 2 equal segments. Postulate 9. An angle has one and only one bisector. The bisector divides the angle into 2 equal angles. That's very similar to postulate 8. Bisectors and midpoints are similar, but for segments and for angles. Very fun. Postulate 10, a circle can be drawn with a given segment as radius and a given point as a center. So you only need 2 bits of information to draw a circle. Postulate 11, all radii of a circle or congruent circles are congruent. That means a radius that is part of a circle that goes to the right is equal to the radius of that same circle that goes up or to the left or down or at any angle. Okay, just a couple more postulates. And here's ones that we're pretty familiar with. I don't agree with the whole thing, but our side triangle congruence postulate. Side triangle congruence postulate. And angle triangle congruence postulate. Excuse me. Next up are theorems. Here's 3 theorems. The vertical angles theorem is the first one we proved. Vertical angles are congruent in shadows, which is a different unit, which you all haven't been a part of in my classes. In shadows, we informally proved these 2 theorems about polygon sides. Oh wait, sorry. This is vertical angles. This is a note about the following theorems, which are the sum of the angles in a triangle is 180 degrees. We've talked about that in our geometry class. And the sum of the angles in a polygon with n sides is 180 degrees times n minus 2. Okay, let's move on. Oh wait, no, I'm going to keep this there. So now we're on but why. So let's look at this. We just want to state a postulate or a theorem that justifies each statement. So here we have x plus 8 equals 15. If x plus 8 equals 15, then x equals 7. Well, if we took away 8 minus 8 from these equals, then what would we be left with? X equals 15 minus 8, which is 7. So therefore, our postulate that we're using is if equals are subtracted from equals, the differences are equal. And I'm going to just write P, I'll show you where I'm reading this. I don't want to write this whole thing down, so I want to write P4. P4. Oh, you know, I'm going to use a different marker. Haha, I'm going to use my pink one. My salmon marker. Ah, great focus. Okay. This one is postulate 4. Question 2. If 6x plus y equals 15, then 3x and 3x plus y equals 9, then 3x equals 6. Wow, what even went on here? I have to draw this out here. So if 6x plus y equals 15, and 3x plus y equals 9, then 3x equals 6. Then 3x equals 6. Wow, I'm actually kind of stumped by that one. Let's think about this. So, then 3x must equal 6. 3x equals 6. Well, how do we know that that's true? Well, we know that the difference between these two is 6, right? So if we took okay, maybe I'm starting to see a little bit. So the difference between these two sides is 6. The difference between these two sides, well, let's see, if we took away y's, then we'd be left with zeros. Then we'd be left with 6x and 3x. Well, the difference between the whole two sides is going to be 3x's, right? This just means we have 6x's and a y, which is equal to 15. And this one we have 3x's and a y, and that's equal to 9. So the remainders, or the difference between the two, must be equal. So let's see if we can find a postulate that matches that. Let's see. It's not about added. The whole equals the sum. 2 points, line segment, line segment. Okay, it's got to be one of these first, 6 or so, or first 5. So, sorry, somebody just rang the doorbell, and but I don't know what's happening. Okay. Okay, any quantity equals itself. I don't think it's P1. 2 quantities equal to a third quantity are equal to each other. I don't think it's that one. If equals are added to equals, then the sums are equal. I think it's postulate 3. So let's think about it this way. So if actually, I'm kind of stumped by this one. I might say something like, I feel like I get why it's that, but I don't know why exactly this postulate works. Maybe it's the whole is equal to the sum of its parts. I don't know. Think about that. See if y'all can figure out one that works best there. Maybe I'm not looking at it right. Y'all often see things better than I do. Plus, this video is also getting long. Okay, if AC equals BD, then AB must equal CD. Well, let's think about that. Isn't AC equal to AB plus BC. So AC is equal to BD plus B. I'm sorry. Oh boy. AC is equal to AB plus BC. And we also know that BD, let's write that over here, BD is equal to DC plus BC. Oh man, I wanted actually these two to line up. Then we know that AB must equal CD or DC. Well, okay, well what if we took away equal parts? So if we took away, wait a minute, where do we say? First of all, we say, we know that this is equal to this, right? So then we'd say that AB plus BC is equal to BC plus CD, right? Because equal, it's this P2, right? Two quantities equal to a third quantity are equal to each other. So we were able to say that these two added, that's P2 for part of it. And then if we took away BC from both sides, so minus BC, then if we took away equals, the remainders must be equal, which is this one. Actually, this was not it. And so that would be, if equals are subtracted from equals, the differences are equal. So that's P4. Focus. Man, geometry is hard. Right, so then those go away, and we're left with AB equals CD, and that's true because of postulate 2 and postulate 4. If the measure of IEG is equal to the measure of TEH, so that means that this and this are congruent, then the measure of IEH is equal to the measure of TEG. Okay, so then that means that this is congruent to this. And that's true because if you have two things that are equal and you add something in an equal thing to both things that are equal, then the sums are equal. And that's P3, I believe. Let's take a look at it once this thing focuses. Yeah, so P3 says if equals are added to equals, the sums are equal. Great, so we know that's true by P3. This is using the same. If IET is equal, IET is equal to IEG plus GEH plus HET, that means the sum is equal to the whole is equal to the sum of its parts. And that would be P5. The whole is equal to the sum of its parts. The angles of a heptagon, a polygon with 7 sides, add up to 900. Oh, okay. I don't know if y'all are as familiar with these as I am, but when I see this polygon, a heptagon meaning a number, poly, many-sided figure, I'm reminded of this final theorem, T3, which is the sum of the angles in a polygon with n sides is 180 times n minus 2. Let's look at that. So just to prove it, so 180 times n minus 2, where n is the number of sides. How many sides does a heptagon have? Well, it says right here, right? 7. Hept means 7. Like if you're familiar with a heptathlon, that's a competition with 7 events. So we do 180 times 7 minus 2, which is 180 times 5. I actually don't know that off the top of my head. I bet it's 900, but we can prove it. 180 times 5 is 900. Okay, great. And that was theorem 3. As the wheels on the bus go round and round, the distance stays the same from the axle to the ground. Okay, what a funny one. Okay, right, so here's our bus. Oh, that's a really flat bus. But the axles are the rods. Oh, that's a measure of some distance. It's the distance from the center of the wheel to the ground. And even though these things are turning, this stays the same. Ah, hey, this is a circle thing, right? That's the radius of the circle. We have one about the radius. A circle can be drawn with a given segment as a radius and a given point at its center. So that's postulate 10. Or no, postulate 11. All radii of a circle or congruent circles are congruent. So that's postulate 11. Whew, almost got me. When I keep switching these packets out, it keeps on unfocusing. If we've reached the midpoint of our trip, then the distance home equals the distance to where we are going. Okay, so if we're driving, here's the United States, of course. That's pretty good. And if we're going to Colorado to Kansas City, Missouri, we've got some segment that tells us, and there's a halfway point of that segment where the distance home, right, back to Colorado is equal to the distance to Kansas City, for example. And that would be our midpoint one, right? So the line segment has one and only one midpoint. The midpoint divides the segment into two equal segments. That's postulate 8. As I operate scissors, the angle between the blades always equals the angle between the handles. Oh, did you know scissors use the vertical angle formula? There's your scissors. Pretty good. And those are two intersecting lines. And what we know about two intersecting lines is that the vertical angles are congruent. So that angle is congruent to that angle, and then this angle is congruent to this angle. And we, of course, know that that is theorem 1, which says the vertical angles theorem, vertical angles are congruent. So that's T1. Okay, and then finally, oh, come on, focus. Shelley and Willie start with the same amount of their savings in their savings accounts and are paid the same monthly interest rate. At the end of the month, the amounts in their accounts are still equals. That sounds like if equals are added to equals, the sums are equal. Does it not? So that'll be, let me show you. If equals are added to equals, the sums are equal. Postulate 3. Hey, and before this video reaches 20 minutes, let's be done. Great work, everyone.